In this lesson, we're going to be looking at ions. So in the previous lessons, we've looked at the three subatomic particles, protons, neutrons, and electrons. We've spoken about their relative mass, their relative charge, their position within the atom. We've also spoken about how protons define which element an atom represents based on the number of protons it has in its nucleus. And we've looked at what happens with variations in number of neutrons in terms of isotopes. So when we're talking about ions, we're talking about variations in the number of electrons. So before we get started, I'd like you to just very quickly fill in this table for the relative mass and relative charge of the three subatomic particles. This should take you no more than 1 minute. So what we should have had is our proton having a relative mass of 1 and a relative charge of +1, our neutron having a relative mass of 1 and a relative charge of 0, and our electron having a relative mass of 1 over 2000 and a relative charge of -1. So ions are formed when atoms undergo chemical reactions, and when they react and when they interact with each other, there's usually a transfer of electrons, forming ions. So atoms themselves have no overall charge because the number of protons in the nucleus is equal to the number of electrons in the shells. So in order for an atom to become an ion, it needs to either lose or gain protons or electrons, because an ion is an atom that has a charge. Now, we already established that if we change the number of protons, we're actually going to change the element. So let's, for example, say we had lithium. Lithium has 3 protons, but if I were to gain a proton, it would no longer be lithium, it would be beryllium. And if I were to lose a proton, it would no longer be lithium, it would be helium. So changing the number of protons doesn't form an ion, it simply changes the element. So it's the number of electrons that must change in order for an ion to form. So the definition of an ion is an atom of an element that has either lost or gained electrons to become either positively or negatively charged. So in order to predict the charge an ion forms or an atom forms when it becomes an ion, we need to know 2 things. Number 1, is it a metal or a non-metal? And number 2, how many electrons are in the outer shell? So we'll start with the first one. How do we identify if an element is a metal or a non-metal? Well, we can predict that from the periodic table. If we have a look at the periodic table, we should be able to identify all the elements that are metals and all of the elements that are non-metals by using something we call the staircase. So if you want to know where the staircase is, because it's not going to be pre-drawn on your periodic table, is you find aluminium. If you go across the top of aluminium, and then, as you would expect with a staircase, down, across, down, across, down, across, down. There is our staircase. So now we have a separation, and everything over here on the left-hand side, with the exception of hydrogen, is a metal. And everything here on the right-hand side is a non-metal. So if I just draw a border, those are all of our non-metals, and everything over here are our metals. So you'll notice the vast majority of the elements in the periodic table are actually metals. It's only these ones here that are non-metals. So by using the staircase, we can identify whether they are metals or non-metals. That's important. So elements left of the staircase are metals and elements right of the staircase are non-metals. So, use your periodic table, use the staircase, you can straight away identify if an element is a metal or a non-metal. And the second bit of information we need to know is how many electrons are in the outer shell of those elements. And if you remember back to electronic configuration, that's as simple as looking at the group number. So the group number is equal to the number of outer shell electrons. So if we look at some examples, magnesium is a metal because it's left of the staircase, and it has 2 electrons in the outer shell because it's in group 2. Phosphorus is a non-metal because it's to the right of the staircase, and it has 5 electrons in the outer shell. Aluminium is left of the staircase, so it's a metal, and it's in group 3, so it has 3 electrons in the outer shell. And then bromine is to the right of the staircase, so it's a non-metal, and it's in group 7, so it has 7 electrons in the outer shell. So once we can identify whether it's a metal or a non-metal, and which group it is in, and therefore how many electrons in the outer shell, we now have everything we need in order to predict the charge of the ion that those atoms will form. So the reason we needed to know whether an element was a metal or a non-metal is because they form ions in different ways. So metals lose electrons. And importantly, they lose all of the electrons in their outer shell. So metals lose all electrons from their outer shell to form positive ions. So if we take an example, let's look at calcium. It's a metal, so it's going to lose electrons. It's in group 2, so it's got 2 in the outer shell, so it's going to lose 2, making it positive 2. Aluminium is a metal, so it's going to lose its outer shell electrons. It's in group 3, so it's going to lose 3 to become positive 3. Lithium is a metal, so it's going to lose its outer shell electrons. It's only got 1 in the outer shell because it's in group 1, so lithium will become positive 1. Non-metals, they gain electrons. And importantly, they gain enough electrons in order to have a full outer shell. So non-metals gain enough electrons to fill their outer shell. And they form negative ions. So let's look at some examples. Nitrogen is in group 5, which means it has 5 electrons in its outer shell. The maximum that shell can hold is 8, so it needs 3 more to get to 8, so nitrogen will become negative 3. Fluorine is in group 7, it's got 7 electrons in its outer shell, it needs 1 more to get to its maximum, which is 8, so fluorine would become negative 1. Sulfur is in group 6, it needs 2 more to get to 8, so sulfur will be negative 2. So metals lose their full outer shell. Whatever outer shell they have, they lose it all. So if it's got 2 in its outer shell, it will lose those to become plus 2. If it had 3 in its outer shell, it will lose all 3 of those to become plus 3. But non-metals gain however many they need to get to a full outer shell, which is usually 8. So nitrogen is in group 5, so it needs 3 more. So nitrogen will form a negative 3 ion. Oxygen is in group 6, it needs 2 more to get to 8, so it will form a negative 2 ion. So what I'd like you to do, and this shouldn't take you any longer than 5 minutes, is look at these elements, use the periodic table in your planner, identify whether they are metals or non-metals, use the group number to work out how many electrons they have in the outer shell, and then I want you to predict the charge of the ion they form. So I'm just going to run through this quickly, and again, make any corrections you need to in green pen. So I'm just going to run down quickly and decide if they're metals or non-metals. So we've got lithium, which is over here, it's left of the staircase, so it is a metal. We have magnesium, again, left of the staircase, it's a metal. Aluminium, left of the staircase, therefore it is a metal. Nitrogen is to the right of the staircase, so it is a non-metal. Sulfur to the right of the staircase is a non-metal. And finally, fluorine again to the right of the staircase is a non-metal. So the number of outer shell electrons, well, lithium is in group 1, so it has 1 outer shell electron. Magnesium is in group 2, so it has 2 outer shell electrons. Aluminium is in group 3, so it has 3 outer shell electrons. Nitrogen is in group 5, so it has 5 outer shell electrons. Sulfur is in group 6, so it has 6 outer shell electrons. And fluorine is in group 7, therefore it has 7 outer shell electrons. And once we have that information, metal or non-metal, and number of outer shell electrons, it's really easy to predict the charge of the ion. So lithium is a metal, which means it will lose its outer shell electrons. It's only got 1, so it's going to be positive 1. The magnesium is a metal, so it's going to lose 2 and become positive 2. The aluminium has 3 in the outer shell, and it's a metal, so it's going to lose all 3 and become positive 3. The non-metals don't lose, they gain. And they gain however many they need to get a full outer shell. So nitrogen already has 5, it only needs 3 more to get to 8, so it'll be negative 3. Sulfur needs 2 more to get to 8, so it'll be negative 2, and fluorine only needs 1 more to get to 8, it'll be negative 1. And it's important to remember that because electrons are negative, if you gain electrons, then your ion will be negative. But if you lose electrons, if you're losing negative electrons, leaving behind the positive protons, that's why the metals form positive ions. So we're going to have a look at the electronic configurations of these atoms and how those electronic configurations change when they become ions. So we're going to start with sodium. So sodium is in period 3, group 1. So sodium, period 3, so it's going to have 3 shells. And it's in group 1, so it's going to have 1 electron in that outer shell, meaning that the inner shells are going to be full. So 2 on the first, 8 in the second. And just double check that adds up to 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay? So sodium is a metal, and when it becomes an ion, it's going to lose its outer shell. So you just redraw it, just you ignore the last shell. You don't draw that third shell, and you don't draw that last electron because it's been lost when it becomes an ion. So it's now going to be Na with only 2 shells because it's lost its outer shell, and it's still going to have 2 in that first shell and 8 in that second shell. So it's only lost that 1 electron in the outer shell. But in order to show that you know that this is an ion, and that you haven't just drawn the electronic configuration of sodium incorrectly, what we do to show it's an ion is we add square brackets to show that it's an ion, and then we add the charge. And the sodium has only lost 1 electron, so its charge is going to be plus 1. Now, non-metals, it's slightly different. So oxygen is in period 2, group 6. So it's got 2 shells because it's in period 2 with 6 in the outer shell. So oxygen, 2 shells, 2 in the first shell, 1, 2, 3, 4, 5, 6 in the second shell. And just double check that adds up. 1, 2, 3, 4, 5, 6, 7, 8. The atomic number of oxygen is 8. Now, oxygen has 6 in the outer shell, but it wants 8, so it's going to gain 2. So we're not going to lose a shell. We're going to have the same number of shells in the ion as we did in the atom. So we're still going to have those 2 shells. And it's not losing any electrons. So all the electrons it had as an atom, it still has. The only difference is it's going to gain 2 more. And I'm going to draw these as dots rather than crosses so that you can see that they're different. So it's gained 2 extra electrons. It's no longer an atom, it's now an ion. And it's gained 2 electrons, so its charge is now -2. So this is the electronic configuration of the atom, and these are the electronic configurations of the ions. So for metals, you simply redraw it without the outer shell, square brackets, and the charge. But for non-metals, you draw it exactly the same, but you just add as many electrons as you need to fill that outer shell, and then again, square brackets and charge. So what I'd like you to do, and this should take you no more than 10 minutes, is I want you to draw the electronic configurations for the atom and then the ion. The atom, then the ion, atom, ion, atom, ion, atom, ion. And again, this should take you 10 minutes. So I'm just going to go through these quickly, and again, make any corrections you need to in green pen. So chlorine is in period 3, group 7. So I need 3 shells with 7 in the outer shell. So chlorine with 1, 2, 3 shells, 7 in the outer shell, which means the inner shells are going to be full. So 2 in that first one, 8 in that second one. And again, it's a non-metal, so we're going to draw the ion exactly the same. So 1, 2, 3 shells, exact same number of electrons, so 7 in the outer shell, 8 in the second shell, and 2 in the first shell, which adds up to 17. But it's a non-metal, so it's going to gain an electron when it becomes an ion. So it only needs to gain 1, because it's already got 7 in the outer shell. It only needs 1 more to become an ion. And then square brackets. And it'll be -1, because it's only gained 1 electron. Beryllium, if we find it quickly, is in period 2, group 2. So it's going to have 2 shells with 2 in the outer shell. So beryllium, 2 shells, 2 in the outer shell, 2 in the inner shell, and it's a metal. Metals lose their entire outer shell, so we're not going to draw this second shell. So we're just going to put beryllium, 1 shell with 2 electrons, square brackets, and how many electrons were in that outer shell it lost? It lost 2, so it's going to be +2. Phosphorus, non-metal in period 3, group 5. So phosphorus, period 3, so 3 shells. Group 5, so 5 in the outer shell. The other shells are going to be full, so 8 in that second shell, and 2 in that first shell. It's a non-metal, so it's going to gain electrons, and it's already got 5 in the outer shell, so it needs to gain 1, 2, 3. So I'm going to draw it exactly the same. 3 shells. Same number of electrons in those shells. And it's going to gain 1, 2, 3, square brackets, -3. Aluminium is in period 3, group 3, so it's going to have 3 shells. And 3 in the outer shell. 1, 2, 3, meaning the other shells are going to be full. So 8 in that second shell, and 2 in that first shell. It's a metal, which means it's going to lose its entire outer shell. So when I redraw it as an ion, I'm only going to draw the first 2 shells. So aluminium, 1, 2. So it had 8 in that second shell, 2 in that first shell, and it lost 1, 2, 3 from the outer shell. So we're going to draw my square brackets, +3. And finally, neon is in period 2, group 0. So it's in period 2, which means it's got 2 shells. And remember, if it's in group 0, that means it has a full outer shell. So it's going to have 2 in the first shell, and the full outer shell will be 8. Now, this was the trick question. Neon will not form an ion because it doesn't need to lose or gain electrons. Because if it was a metal, it would lose its outer shell, and if it was a non-metal, it would gain electrons to fill its outer shell. So neon is found here. It's a non-metal. How many does it need to gain to fill its outer shell? None. It's already got a full outer shell. So noble gases do not form ions. So here we have a table that contains some information about some different atoms and ions. Okay, and what you need to do is fill in the blanks. Now you've been given enough information about each one to be able to fill in the whole row. Okay, so I'll do a few for you and then you're going to get on with the rest. So if we take this one here, calcium. So the fact that it's calcium means you can look at it up on the periodic table. It's got an atomic number of 20, which means it must have 20 protons. Now we can see from the symbol it isn't positive, it isn't negative, so it's not an ion, it's an atom. And if it's an atom, it means it must have the same number of protons as electrons. So if it's got 20 protons, it must have 20 electrons. And its electronic configuration, it's in period 4. So it's going to be 2, 8, 8, and then in that fourth shell, it's in group 2, so it will be 2. So it's going to be 2, 8, 8, 2. Let's take another one where you know a little bit less. So let's have a look at one of these. So we know the number of protons, we know the number of electrons. So straight away, the number of protons and the number of electrons is not the same. So it's an ion. We can see how many electrons it has. It has 18. So that would be 2 in the first shell, 8 in the second, and then 8 in the third, giving you 18 electrons. So now we just need to identify which element it is. And we can do that from the number of protons. The number of protons is the same as the atomic number. So let's find the element with the atomic number 19. It's potassium. So the element is potassium. And importantly, it's not an atom, it's an ion. It's lost 1 electron, so it's going to be potassium 1+. And the last one I'm going to go through is one of these ones down the bottom. So This one here, number of protons, 7. And if we use the electronic configuration, we can see the total number of electrons. 2 plus 8 is 10. So it has 7 protons, but it has 10 electrons. So it has more electrons than protons, so it must be an ion. And if we find which element we're talking about with the atomic number 7, it's nitrogen. And in order for it to have 10 electrons, it has 3 more electrons than protons, so it must be 3 minus. So you've got 10 minutes to fill in all the blanks in this table using your knowledge and the periodic table. So I'm just going to go through this now. Again, make any corrections you need to in green pen. So the first one here, sodium, has an atomic number of 11, so it must have 11 protons. It doesn't have a charge, so it's not an ion, which means it must have 11 electrons, making it an atom. And its electronic configuration is going to be 2, 8, 1. This one here, whatever it is, it has 9 protons. So we look for the element with the atomic number 9, which is fluorine. It's an atom, which means it's going to have the same number of electrons as protons, and its electronic configuration is going to be 2, 7. The next one here, the number of protons is 17. So atomic number 17 is chlorine. It has 17 protons, 18 electrons. So it doesn't have the same number, so it must be an ion. It's got 1 more electron than proton, so its charge is going to be 1 minus. And the electronic configuration is going to be 2, 8, 8, which adds up to 18. This one here also has a number of protons of 17, so this must also be chlorine. But this time it has the same number of electrons and protons, so this time it must be an atom of chlorine. So our electronic configuration, we need to add up to 17 this time, so 2, 8, 7. So the next one here, number of protons is 18, so the atomic number 18 is argon. 18 protons, 18 electrons, so it is an atom. Electronic configuration of 2, 8, 8. Number of protons 1, so atomic number 1, so that is hydrogen. Number of electrons 0, so it is an ion. So if it's got one proton and no electrons, its overall charge must be 1 plus. And its electronic configuration is blank. There are no electrons. Number of protons 4, atomic number 4 is beryllium. So whatever this is, it is beryllium. And the electronic configuration is 2. So it means it must only have 2 electrons, which is less than the number of protons, which means it's an ion. So it must have lost 2 electrons, so it's 2 plus. Number of protons 12, giving us magnesium. The electronic configuration 2, 8, that adds up to 10, which is less than 12, so this again must be an ion. It's 2 less, so again that must be 2 plus. 13, that's aluminium. Looking at the electronic configuration, again 2, 8, so in total that is 10. So it's less than the number of protons, so it must be an ion. It's 3 less, so it must be 3 plus. Number of protons 8, which is oxygen. And again, 2, 8 giving us 10 electrons, which is different to the number of protons, so it must be an ion. This time it's 2 more electrons than protons, so this must be 2 minus. and then the number of protons, 9, is fluorine. Again, 2, 8, so that's 10 electrons, different to the number of protons, so it must be an ion. It's 1 more, so it must be 1 minus. And finally, atomic number 10, neon. Electronic configuration 2, 8, which if you add that up is 10. 10 and 10, it must be an atom. So what I'd like you to do now is have a look at this table below. We've got 2 metals, 2 non-metals, their group numbers, and the charge of their ion. I want you to just take 2 minutes to have a look at that and see if you can come up with the pattern that links the group number to the charge of the ion. So what we might have found is for sodium, the group number is 1 and the charge of the ion is +1. And for magnesium, the group number is 2 and the charge of the ion is +2. But when it comes to oxygen and chlorine, that doesn't work, because oxygen, the group number is 6 and the charge of the ion is 2 minus. And for chlorine, the group number is 7 and the charge is 7 minus. But the thing that distinguishes these is that the first 2 were metals, the second 2 were non-metals. And remember, metals and non-metals form ions in different ways. Metals lose electrons to become positive, whereas non-metals gain to become negative. So for metals, it's nice and simple. Whatever the group number is, that is the charge of the ion. If the group number is 2, it's +2. If the group number is 1, it's +1. If the group number was 3, it would be +3. So for metals, the group number is equal to the charge of the ion. For non-metals, it's a little bit different. For non-metals, it's about how many electrons they need to get a full outer shell. But if we remember that a full outer shell is going to be 8, so if we just take the group number and then subtract 8, we will find the charge. 6 minus 8 is -2. 7 minus 8 is -1. So for non-metals, the group number -8 gives us the charge of the ion. So group number -8 equals the charge of the ion. So for metals, whatever the group number is, that is the charge of the ion. And for non-metals, the group number -8 gives us the charge of the ion. So to finish off this lesson, we have a 10-question facts test covering questions from the first 4 lessons we've done so far. So if you just work through that, answering those questions, and you have 10 minutes to do that. Okay, I'm just going to go through the answers quickly. As per usual, mark them off if you got them correct, correct in green pen if you got them wrong, and then at the end give yourself a score out of 10. So, how many electrons does an ion of oxygen have? So, oxygen atoms will have 8 protons, meaning they'll have 8 electrons, but an ion of oxygen, because it's in group 6, will gain 2 electrons. So if it had 8 to start with, but it gains 2 more, it would have 10. How many neutrons are in chlorine 37? So if the relative mass is 37, or the mass number is 37, and the atomic number is 17, the number of neutrons is always the mass number minus the atomic number, giving us 20 neutrons. How many protons are in an ion of oxygen? Now, the fact that it's an ion is irrelevant. Whether it's an ion, or whether it's an isotope, or whether it's an atom, all oxygen atoms have the same number of protons. So you find the atomic number, 8, it has 8 protons. What is the relative mass of a neutron? It has a relative mass of 1. How many electrons are in the outer shell of sodium? Sodium is in group 1, so it has 1 electron in the outer shell. How many electrons does an atom of calcium have? Find calcium on the periodic table. Atomic number of 20, meaning it's got 20 protons, which means it will have 20 electrons because it's an atom. What charge do group 6 elements form? What charge ion do group 6 elements form? So group 6 elements are non-metals, which means it is their group number minus 8, which equals minus 2. Which subatomic particle was discovered first? The first one to be discovered was the electron by J.J. Thomson. If an element has 3 shells and 7 electrons in the outer shell, what element is it? So 3 shells means it's in period 3, 1, 2, 3, and 7 in the outer shell means it's in group 7. So period 3, group 7 is chlorine. And what charge ion do group 7 elements form? Again, group 7 elements are non-metals, so it is group number 7 minus 8, which equals -1. So mark those, give yourself a score out of 10, and correct any that you got wrong in green pen.